Hello students, in this class we study about the demultiplexer. So what do you mean by a multiplexer? Multiplexer is many to one, that we call as the multiplexer. Many input and only one output. But the demultiplexer, it will do the reverse function of the multiplexer, that is one to many. One to many. So we are having only one input and we are having only one input and we are having the multi outputs, so that we call as the demultiplexer, that is demux, that is 1 is to 2 raised to n output, 1 is to 2 raised to n output, so that we call as the demultiplexer, that is 1 is to 2 raised to n output, where n is equal to 1, then it is 1 is to 2 output. When n equal to 2, 1 is to 4 output. When n equal to 3, that is 1 is to 8 output. So that is the demultiplexer are of the 1 is to 8 demultiplexer, 1 is to 2 demultiplexer, 1 is to 4 demultiplexer, 1 is to 8 demultiplexer, and so on, that is 1 is to 2 raised to n, 2 raised to n. So in this case we are having same as for the multiplexer, where n will be the number of the selector inputs. So here the selector switch is only one, here the selector switch is only one, and here the selector switch is 2, here the selector switch is 3. So like this we are having the multiplexers, that is demultiplexer. So it takes digital information from one line and distributes it to a given number of output lines. For this reason, the demultiplexer is also known as the data distributor. The decoders can also be used as demultiplexer. So decoders can also be used as the demultiplexer. The main difference between the multiplexer and a demultiplexer is that a multiplexer takes two or more signals and encodes them on a wire, whereas multiplexer does reverse to what the multiplexer does. Okay, that is, the multiplexer will receives different inputs and it encodes and it gives only one output. But demultiplexer, it will receives one input and it will decodes and it will distribute it to the different outputs. So encoding action is mainly done in the multiplexer and decoding action is mainly done in the demultiplexer. Okay. So what is a demultiplexer? A demultiplexer is a digital switch with a single input source and a multi-output destination. Single input and multi-output. The select lines determines which output the input is connected to. So we are having different outputs here. We can see the demultiplexer, we are having different output. So different outputs, say 4 outputs, and we are having the two selector inputs, that is 1 is to 4, where 2 raised to 2, that is 2 selector switches and 4 outputs. So here we are having 2 selector switches and this is the input here and this will be the output. So here the selector lines determines which output is connected to the input. So if the selector switches determines to connect this one, then it should be 0 0. If it is 0 1, then it will connect to here. If it is 0 2, if it is 1 0, then it will be connected to here. If it is 1 1, then it will be connected to here. That is I1, I0, I1, I2, I3. Okay. So that is 1 is to 4 demultiplexer. As in figure, of 4 line demultiplexer circuit, the data input lines goes to all AND gates. The two data select lines enables only one gate at a time, and the data appearing on the data input line will pass through the selected gate to the associated data output line. In a demultiplexer, data are switched from one line to the several lines. One line to the several. So we just see this one. See here in the demultiplexer, we are having only one input, and this input is being connected. See, this X is being connected to the AND gate. This AND gate, and we are having A, B, and this A, B, you just see the truth table here. See the truth table here. See the truth table. So what is the output of an AND gate? AND gate, when the both input are high, then the output will be higher. When the both input are high, then the output will be higher. Though, so here uh, so here we can see we are giving, so here we can see we are giving the A complement here and B complement here, and we are giving A is equal to B is equal to 0 here. 0 complement is what? 1. So both input are 1, and this input is 1, always 1, and this, when 3 input of the AND gate is high, then the output will be high. Okay, so here if you are connecting, so you can see, okay, so for the same thing we are giving 0 0 here, A equal to 0, B equal to 0 here. For this one, for here also it is 0, for here also it is 0, for here also it is 0. So that is why this D1, D2, D3 gates will not work when D1 is higher. When D1 is higher. See here, this D0 gate, this it will be 1 here. The after passing through the NOT gate 0, after passing through the NOT gate it will be 1. So this will be the high. So I will just show it by the green line. So this gate will be at higher. This gate will be at see, this gate will be at higher. But what happens? This gate will be at higher input. But what happens here? But what happens here? Due to this low input, due to this low input, that is 0 is being passed to this gate. So here it is 0 here. So that is D1 is off. D1 is off. So D1 is off, D2 is off, D3 is also off. Only D0 will be on. So next one we are connecting the A01. 01 means B is equal to 0 and A is equal to 1. B is equal to 0 and A is equal to 1. So now what happens? We are if you are connecting like this, then when B is equal to 0, the complement value will be 1. When A is equal to 0, the complement value will be 1. For D1, we need to connect for B complement. One gate should be connected for B complement, that we have done, and the other gate should be connected to the A, that we have already done. And the other gate, the other input should be connected to the X. The X input will be always higher. The one is higher. The complement value 1 is also higher. So the D1 is higher. So similarly, we can see that for D2, for D2 we can have the gate like this. For D2 we can have the gate like this. So X we can have, and the other input should be BA, that is 1 0. So we need to connect directly B, and we need to connect the NOT of the A. From the NOT gate we need to connect so that we get at D2. So whether we see it is being implemented here at the right sense. Yes, see here you can see D2, it is being connected to A, that is NOT gate, B here, it is B here, and X here. It is A complement B, A complement B and X. So that is why when it becomes 0 1 and then it becomes higher. Then when it becomes 1 0, then it becomes higher. Similarly for D3, you can see for D3 we need to see that it should be connected to X, A and B. X, A and B, that is being done here. Then that is being done here, directly connected to the X, directly connected to the A, directly connected to the that B, directly connected to the B, directly connected to the A. Then we get 1 here, when the then the rest of the gate will be 0. So the data selector lines will select the which output should be, the input should be given to the which output. That thing will be selected from the data selector line. ഡാറ്റ സെലക്ടർ ലൈൻ ഉപയോഗിച്ച് നമുക്ക് എന്താ ചെയ്യുക, ഏത് ഈ ഇൻപുട്ട് ഏത് ഔട്ട്പുട്ടിലേക്കാണ് നിങ്ങൾ ഡിസ്ട്രിബ്യൂട്ട് ചെയ്യേണ്ടത് എന്ന് നിങ്ങൾക്ക് സെലക്ട് ചെയ്യാൻ പറ്റും ഡാറ്റ സെലക്ടർ ലൈൻസ് ഉപയോഗിച്ചിട്ട്. സോ ഓക്കെ ഫൈൻ. 1:8 demultiplexer. It has 3 selector lines. 3 selector lines. So how you came to know that it is 3 selector lines? 2 raised to n. 2 raised to 1 means 2 raised to 3. Then 3 selector lines. 3 selector lines. 2 raised to 3, that is what? 2 raised to 3 is 8. Okay. So then we can see the demultiplexer 1:8 demultiplexer, and here D0, Y0, Y1, Y2 and up to Y7, S2, S1, S0 and data input D input. So this is the implementation of D. This is what of 1:8 demultiplexer. When say for S2, S1 and S0 is 0 1 0, can you guess which output should be higher? Yes, it should be Y1 0 1 0, then it is Y0, Y1 Y2, sorry, it should be Y2, then if it is having the 0 0 0 1 0 0, can you guess? It is for 4 2. So for 1 0 0, which output should be higher? Y4 should be higher. So same thing here, we can see the D is being represented. D is the input and the input is represented in the Y0. When S1 S0 S1 S2 is 0, then Y0 is equal to D. When S0 S1 S2 is 1 0 0 1, then Y1 is equal to D. When it is 0 1 0, then Y2 equal to D. Then diagonally we can write down like that. So same thing we can implement this 1:8 demultiplexer similarly as we implemented for 1:4 demultiplexer. So here we need to have the 3. Here we need to have one S2, S1 and S0 signal, and we need to connect a NOT gate also. We need to connect a NOT gate also. And we can see that for D, and we need to have 4 input AND gate. For X we need to have 1 input, and for S2 we have 1 S2 S1 S0 we need to have 3 plus 1 4 input AND gate is very much necessary. Say for implementing Wi-Fi is what? 4 2 1, that is 1 0 1. So for 1 0 1 we can have, once if you are giving 1 0 1, so if you give 0 here, then what happens? 0 should be complemented and the output should be what? Output should be higher, that is it should be higher. Then if you give 1 here, 1 should not be complemented, then the high of the 1 should be kept, so high should be kept. So this x is always high. So what we can do, we can make the we can take directly from S2 we can directly take. Then we can take the complemented value of S1, and we can take the S0 directly, and the x is already is there. Then this 4 output is being, this 4 input is being fed to the AND gate, and this forms your D5. That is S0, S1, S2 and X. This forms your D5. For that I will just write it down and I will show you. See here, for say for y6, we are having 4 to 1, that is 110. 4 to 1 we are having 110. So for that one, S2, S1, S0, that is 110. Then what we can do is, we can have the input of the AND gate as 4 input, x1, 4, this one S2, this one S1, and S0 we need to take it from the NOT gate. So like that we can have for D6. So similarly you can write it for anything. So that is, this should be connected. അത് താഴെ വെർട്ടിക്കലായിട്ട് നിങ്ങളത് വരച്ചിട്ട് ഇത് ഹൊറിസോണ്ടലായിട്ട് ഇതിങ്ങനെ നിങ്ങൾ കണക്ട് ചെയ്ത് കഴിഞ്ഞാൽ തന്നെ നിങ്ങൾക്ക് ഈസി ആയിട്ട് അതാവും, മനസ്സിലാവും. സോ ഇത്രയേ ഉള്ളൂ. ഇത് സിമ്പിളാണ്. അപ്പോൾ ഇതിൻ്റെ ഇംപ്ലിമെൻറ്റേഷനും വളരെ സിമ്പിളാണ്. So application of demultiplexer is mainly used for the communication system. Demultiplexer receives signals output from multiplexer. As at the receiver end, it converts them back to the original form. Arithmetic logic unit. The output of the ALU is fed as the input to the digital multiplexer. Demultiplexer. The output of the ALU is fed as the input to the demultiplexer, and the output of the demultiplexer is connected to the multiple registers. That is the output of the arithmetic logic unit, ALU output is being fed to the demultiplexer. ALU output is fed as an input to the demultiplexer, and the output of the demultiplexer is being connected to, the output of the is connected to the multiple register to store the data. From the ALU, the output is being connected to demultiplexer. Then so why we need to connect for demultiplexer? Demultiplexer, it decodes and it will convert it into the original signal. അതായത് നിങ്ങൾ സിഗ്നൽ ട്രാൻസ്മിറ്റ് ചെയ്യുമ്പോൾ, അതായത് ദൂരെ സിഗ്നൽ ട്രാൻസ്മിറ്റ് ചെയ്യുമ്പോൾ അത് ഡിജിറ്റൽ വാല്യൂവിൽ നിങ്ങൾ സിഗ്നൽ ട്രാൻസ്മിറ്റ് ചെയ്യും. ആ ഡിജിറ്റൽ സിഗ്നൽ ട്രാൻസ്മിറ്റ് ചെയ്തത് നിങ്ങൾ എന്ത് ചെയ്തു, ഡീമൾട്ടിപ്ലെക്സർ അത് ഡീകോഡ് ചെയ്തിട്ട് അത് ഏത് സിഗ്നലിലേക്ക് ആയിട്ട് മാറ്റും, അത് അനലോഗ് സിഗ്നലിലേക്ക് ആക്കി മാറ്റും. ആ അനലോഗ് സിഗ്നലാണ് നിങ്ങൾ ഏതിലേക്ക് ഉണ്ടാവുക, ഒരു ഡീമൾട്ടിപ്ലെക്സർ അത് കൺവേർട്ട് ചെയ്യും. ഡീമൾട്ടിപ്ലെക്സർ നിങ്ങളുടെ അനലോഗ് സിഗ്നലിനെ എന്ത് ചെയ്തു, അത് അനലോഗ് സിഗ്നലാക്കി മാറ്റി അതൊരു മൾട്ടിപ്പിൾ രജിസ്റ്ററിൽ സ്റ്റോർ ചെയ്തിട്ട് വെക്കും. ഓക്കെ. So series of parallel converters. This converter is used to construct parallel data. Serial data is given as an input to the demultiplexer at a regular interval. A counter is attached to detect the signal. So at this sending end, we usually put the multiplexer, and at the receiving end, we usually find the demultiplexer. Mux is being fed at the sending end, and at the receiving end we use to feed the demultiplexer. So this is the typical application of a demultiplexer to select. So we are having different outputs, So we need to just keep control P. So if you want to give for select the laser, printer, fax machine, cooler or pen plotter, whatever the data is there. So only one input, so different output. So thank you for watching this video fully. Thank you.